And the last part also is I think is the most important part, because about the VCS working principle and the configuration, it's very easy for us to understand, right? But the limitation, you have to know. Maybe in the future, you want to use this feature. You want to use deploy the VCS in your network, and some special part you have to know before you use this technology. The first is the VCL ports. We also have some applications and limitations. We can see one by one. And what's the meaning of it? The first is the application devices. NBS 7003 and 7006, whose VCL ports can be connected only if their ID domains are same. And the ID domain ID cannot be changed on this NBS switch. So only 7000 and 7006, they can form VCS. And both the 7003, they can form, but 3 and 6, they cannot. So pay attention about this one. And the next part about the VCL. The VCL, one device can be configured with a group of 1 to 4 VCL ports. That means at least one VCL. And the most number is 4. You cannot use 8 or maybe some 6, something like this. Okay, so this is the second one. And another one is about the VCL ports cannot be grouped across the line cards. That means in the same switch, okay, you cannot use the line 1 and the line 2, slot 1 and slot 2. One of the interface to become the VCL cannot, because they cannot cross the line cards. And another one is VCL ports cannot be grouped across the line cards shape. So this is a special for the line cards of this one. About these line cards, we can support 16 10 gigabit interface. But the first 10 ports use one chip, and the later 6 ports use another chip. That means maybe you want to use 4 ports to become VCL. All of them in the located on the first 10 ports, or maybe all of them located in the last 6 ports. Cannot, they are 3, they are 1, cannot. So this also is a limitation. And here is the limitation of the bandwidth, right? We must be 10 gigabit optical ports. And another is VCL ports cannot be for exchange service purpose. And the traffic status can be cleared. That means the VCL is used for example, very special paths. We must forwarding to switch 1 to switch 2. Otherwise, if switch 1 receives this message, we must send out the message out directly from the switch 1. Cannot send to the switch 2 and then to forward the message out. And the next part is the DAD aggregation and layer 3 routing ports. These 3 types, that means some special interface, we already add this feature. This interface cannot be VCL. If you delete this function, then this interface can become the VCL member. If the port in the upper status cannot join the exiting VCL port group. So maybe first time you already connect with one cable with each other, right? And you finish with the configuration of the VCL. Then if you want to add another link to connect with each other to make the VCL link more reliability, in the down status, you can add the VCL configuration first. Then you can use a cable to connect with each other. So this is a limitation. And if the line card goes offline or maybe broken, you can delete the VCL ports, then configure another 10 gigabit optical ports to become VCL. And delete is not supported if there is only one VCL port. That means if you enable the VCS function, at least one VCL port. So this is a limitation of the VCL. Do you have any question here? If no more question, we can continue next part about some member switches operation. For example, if some scenario you will add more switches in your VCS. Generally, we will use 2 switches to become the VCS feature. And in some scenario, maybe you configure 1 switch to become the VCS function, and then you add a new one here. If the first switch already selected to become the active switch, although the second one to become higher priority, they still only can be the standby switch. So this is the first scenario if you want to add more switch on the VCS. The second one is removing a member switch. We can divide 2 scenarios. First is standby switch is removed. If standby switch is removed, it doesn't matter, right? Because your active switch also is working. And which scenario we will have the standby switch will be removed? First is standby switch supervision model is removed or maybe faulty, or maybe the VCL links are disconnected. Maybe the link is broken, or maybe the interface is broken, or maybe the line card is broken. And the third scenario, maybe the standby switch is power off. So in this scenario, the standby switch will be removed from the VCS. And another one is active switch is removed. Pay attention. If the active switch is removed, we must select the new one to become active. So the standby switch will direct it to become active switch. And also 3 scenarios. If the active switch supervision model is removed or maybe faulty, or maybe the VCL link is broken, or maybe the active switch is power off. In these 3 scenarios, the active switch is removed. Then we will select the standby switch to become a new active switch. Then we can continue to work. So about these 2 actions is very good because we don't have any influence about our network.
Sorry, I have a question here. Is the active switch removed supposed to be the standby switch will work immediately without my input, right? I don't need to add something. My configuration and my scenario, the standby switch is ready to start up once something happens with the active switch. If the active switch down, broken, or switch off, the standby switch immediately will take over all connection without any human input. I'm correct?
Yes, right? Yes. Okay. Because before the active switch is removed, the standby switch already get everything from the active switch.
Exactly.
Except working. But I already get everything.
Okay.
Yes.
Thank you.
So we only need time to detect the active switch is not working. After I detect, I make sure I will immediately to become new active. And the special function of the DAD, we have talked about the detail because this one is very important. About the last page, if you add a new switch, or maybe I detect the active is not working, I become a new active. This is a good performance because I already get everything. I don't have any influence about our current network, right? This is good. But some not good phenomena is, for example, I cannot get any voice from my active switch. I will immediately to become new active, but the original active switch still is working. So in this scenario is the first one we say here. If in your network, there are 2 active switches, there's some problem. If we only have 1 active switch, it's okay. Anyone to become active can work because we already get everything. But in your network, if you coexisted have 2 active switches, there's some problem because some special configuration like the layer 3 interface of the VLAN interface, loopback interface, and some OSPF protocol, something like this. These 2 switches have the same information. So maybe someone maybe say, why I have 2 gateway? Why I have 2 next hop who can help us to forward the message successfully? So in this scenario, we have 2 special configuration, special detect. I will show you. Although maybe now the VCL cannot work, that's why the standby will think the active switch is broken, right? Because maybe the line card of the VCL, this line card totally cannot work. So I will find my active switch is broken. But in the real time, the device can work, but the VCL link cannot. So in this scenario, if we have some special other path to show you, I still can receive this message from my active switch. In this scenario, I will stop my physical interface because if your interface, your physical interface is still working to help us for the message, there is a problem like the VLAN and the loopback interface have the same IP address, something like this, right? So if the function we already detect my active switch is working, cannot working is the VCL. So if I detect this scenario, I will directly to stop all the interface, but except our VCL interface. Maybe later the VCL link is working, I still can receive the negotiated parameters from active switches. Then I can make all the interface data to become enabled. So this is the function of the DAD. For example, between them, we will use two line cards to establish the VCS and 2 link to become the VCL and another one for the DAD link. Okay, for the DAD link. So about this DAD link, we don't have any limitation. Each interface, all the interface can work with each other. Then if I still can receive the detect message through the DAD link, that means the active switch still is working. But I cannot receive anything from the VCL link because maybe this link cannot work. So I also will make my status to become active, but only the VCL interface in the enable status. But all the other interface, like this one, this one, this one, to connect with each other, this interface, the state will be disabled. Okay, so if I still can receive the message from the VCL again, that means now the VCS can work. I will join to use the join rule to compare the priority and then to become standby. And then about the control plan, I will in the standby status, but the forwarding plan, I will in the active status to help us forward the message out. So these are the function of the DAD. Okay, so the result is if 2 active switches are detected, the origin standby status will enter the special mode. We call it restoration mode. And then all the ports except the VCL will directly to become disabled. After the VCL is restored, that means we recover everything. The standby switch automatically restarts and rejoins the VCS. as the standby switches. So this is the function. But about the configuration, it's very easy. I showed you before. You only click one interface to enable the DAD function. It's enough. How to send the private message, how to do the encapsulation, how long I send to my active switch or maybe standby switch, how to detect, and if there are two active switch, how to disable the service interface, something like this. All the devices will know this function and they will do automatically. About you only understand the DAD function and select the special interface to become DAD interface. It's enough. So the configuration is very easy. This is a function about the DAD. And about this function, do you have any question? Any question about this part? If no more question, we will go to the next part about the synchronization. The synchronization is very easy because if we select config the VCS successfully and select who is active switch, who is standby switch, then the standby switch will get the synchronization configuration automatically. And if we do any configuration, the active switch will send to the standby switch in real time. So that's why one person asked me is that we only need to detect, right? And then the standby can be active and then they can work because we get everything when we use configuration synchronization. And about this synchronization, we will finish on the devices, on the local devices. We don't need any feature of the radio cloud. So this is synchronization. And another one about the software upgrades. If the active switch is upgraded with a new version, gets the installation package, then our supervisor model will automatically synchronize the software version and the line card, all of them, to the standby switch. So we're also very easy to do the upgrade at the same time or maybe one by one. So it's this is a synchronization and software upgrade. And another feature about the VCS high reliability, we can support, the first is provides a cross-switch supervisor model redundancy, right? For example, if you use the NBS 7003, one device, one supervisor model, and if you use two devices together, we can have two supervisor model. If one is active and another one is standby. If one switch is broken, we can continue to use another one. So this is the supervisor redundancy, okay? And about this one, we can remove it in the hot mode. So this is a special for our supervisor mode. And another one redundancy is about the VCL. You can add more VCL interface to provide high reliability, but we have the number limitation, up to 4 interfaces. So this is a limitation. So we suggest at least 2 interfaces will be better. If one link is broken, and we still can use another link to detect the state of active and standby. Because if your VCL is broken and you don't enable the DAD function, maybe in your network there are 2 active switches. Maybe some problem will happen when you forward the message out. And about the VCL, we can make the detect time from 50 to 500 milliseconds. And about the protocol hot backup, we can support the routing protocol OSPF v2 and support the GR technology. If you already enable this function in our NBS switch and we use VCS, then if the standby switch take over the faulty active switch, that means now the active switch is broken, I need 50 to 500 milliseconds to detect. Within this time, if we don't detect successfully, we still can force a message out. Of course, first step is you already enable the OSPF v2 GR function. OSPF v2 is the dynamic routing protocol OSPF working in IPv4 network. If in the IPv6 network, we call OSPF v3. So this is a high reliability. And another one is cross switch aggregate link. If we already enable this function, VCS function successfully, then maybe you make some aggregate links. And about this interface also may be located in different line card. It also can enable faster switch over to another link. For example, maybe at the beginning, the message will be sent out on the slot 1, interface 1. And now this interface is broken, we can immediately change the message to slot 2, interface 2, because we do the aggregate link. So this also is a high reliability. And some typical application scenario. The first is usually in the core switch, because the core switch is very important. If you only have one core switch, this switch is broken, lots of segments cannot force a message out. So in this scenario, you can deploy multiple switch to become VCS. If one switch is broken, we can continue to use the second one. The standby will become a new active. So this is the first scenario. And the second scenario may be about the access layer. The interface is not enough. For example, the first interface, you use some special switch, only supports the 24 interface, but you have lots of terminal. It's not enough. If you can deploy this switch and you can add lots of line cards to extending your interface. Of course, if you want to use the 7,000 switches as a distribute or maybe access network, your network size will be very big. So they are a typical scenario. We usually can use the VCS. That's all about today's topic about the VCS and the hardware.